Okay, let's talk about doing a sorted insert in a given linked list. Now sorted insert means if linked list already has 1, 2, 5 and we are inserting 4, then 4 should be inserted in between 2 and 5 because we want to keep it sorted. So this is called sorted insert. Now let's take care of all the cases in sorted insert. There is a possibility that there is insertion at beginning, it can be in middle, or it can be at end, and we have to make sure whatever code we write will satisfy all these criterias. So insertion in beginning will be the case if linked list is, let's say, 2, 3, 4 and we are saying go and insert 1 in the linked list. So now we know 1, if we are inserting, it has to be inserted in the beginning. So let's do this. First we need to create the node that we want to insert. So we say ll node n is equal to new ll node, and let's put the data in that. So this is just creating the node, and then we'll figure out where the node fits in. Now insertion and beginning, there will be only two cases. First case is if head is null. If linked list does not have any node, then we know 100% that we are inserting at the beginning. Second possibility is or. If h is not null and we say head dot data that we have is greater than the data that we are inserting. So if the first node data happens to be 2, 3, 4 and our data that we want to insert is 1, so 1 is in data and h dot data is 2. So we say 2 is greater than 1. If that happens to be the case, then 1 has to be inserted in the beginning. So in both these cases, what we can say is head dot, new node that we created, n dot next is equal to head. Right, so this is insertion in beginning, like point rest of the list after new node, and once we do that we will say new node is the head and we have done the insertion. So this is the first case that we have taken care of. Now let's talk about the remaining case. If this does not happen to be the case, that value that we are inserting is not less than the first node, then what we will do is we will try to find the node whose value is bigger than our value. So if this happens to be 2, 4, 6 and we are inserting 3, we compare 3 with our current node and we say no, current node is less than 3, so we don't want to insert right now. Then we come here, we say oh, this is 4, we wanted to insert 3, so we have found a node before which we should do the insertion. So before 4, 3 should be inserted. So let's go ahead in the complete linked list and find a node whose value is greater than 3. Now possibility is we will find that node, and possibility is we will not find that node, because another case would have been 1, 2. If 1, 2 is there and we are trying to find a node which is greater than 3, we see 1 is not greater than 3, 2 is not greater than 3, and ultimately we reach the end. So if we reach the end, we know we have to do the insertion in the end. So at the end case we will talk about later. Right now let's go with insertion somewhere in the middle. So we take a C pointer head, P which is previous, and we initialize that with null, and we run a while loop. While C not equal to null, what we do is we keep on going till current value is greater than the value that we want to insert. So what we will do is if C dot data is greater than the data, then we say C equals C dot next. But if that is not the case, if we come to the else case, that means we have found a node whose value, there is a correction needed here. So if we have found a node whose data is greater than the data we want to insert, so if this happens to be the case, then we have found the point of insertion. So we know we have to do the insertion here before C. So if we want to insert before C, we will say P dot next equals, so previous we already have, equals new node, and we will say n dot next equals C. Right, so ultimately we are saying in 1, 3, 5 we were inserting 4. So when we are inserting 4, C will stop here because we will say C dot data is greater than our data, and what we are doing is previous will stop here. So we are saying previous dot next is equal to n. Now n is the node that we created in the beginning, n is the node which has the value 4, and this is null. So we are saying p dot next is n, so that is the linking we are doing, and then we are saying n dot n is nothing but n dot next is nothing but C. So this if we do, then we say insertion is done. And whenever we have done this insertion, we will be returning the original head, because here we have done insertion in the middle. Now imagine what will happen if linked list was 1, 2, 3 and we are inserting 4. Then this while loop will end without doing the insertion, right? Because if we are inserting 4, this is not greater than 4, this is not greater than 4, this is not greater than 4, so eventually C will become null. But if C becomes null, P will be pointing to the last node. So after coming out of the loop, eventually we will say here, if we have come out of the loop, we say P dot next is equal to N, and again the head remains head, right? So this is at a high level the logic. Now we have to make sure of one more thing. Here right now the while loop is infinite loop, because we are not changing C, we are not moving C ahead. So we'll say C is equal to C dot next, and here we will say P equals to C. So now we have taken care of insertion in the beginning, in the middle, in the end. Let's validate our two corner cases. What if the linked list was empty and we were doing the insertion of a value? So if head is null, here we are creating a new node, and we are saying if head is null, whatever new node we created, new node next is head, and we are returning the new node. So that will be fine. So if linked list was null and we are inserting 5, so this will be N, this will be next, and we are saying in N next, go ahead and put H, which is null. So null case is already taken care of. Let's look at the case of only one node. So one node was 2 and we are inserting 1 here. So let's say how the insertion of 1 will happen. So again we create a node with 1, that is N. So this is our N, this is our head. Now we check. If head is null, that is not true. So if first condition is false, it will evaluate the second. Is head data greater than our data? So our data is 1, head data is 2. So this happens to be true. So we go inside the first if condition and we say N dot next, which is this, points to head. So this is what we did, and we are returning N here. So we are returning 1. So we say 1, 2 is the linked list. So this case is also handled. One case is we had only one node as 2 and this is our head, and we are inserting 3. So we will be creating the node 3 first, which will be N. So we have created the node. Now these conditions will not hold true, because head is not null and head dot data is not greater than our data. So what we do, we go here and we start running this loop. So we start C from head, so C will be pointing here. Inside the loop we check C dot data greater than data. So this 2 is not greater than our value 3. So if this if condition is not true, if this is not true, what we were doing was we were moving C ahead. Before moving C ahead, we were bringing P here. So let's see. So we are bringing P here to current node, C we are moving ahead. So eventually what will happen is C will become null. We will go out of the linked list because there was only one node in the linked list, and loop will break and we come here at the end. Now whenever we come at the end, what we are doing is whatever is previous, that is first node 2, so 2 next we are putting the new node. So that will be 2 next will point to 3 and we are returning the original head. So these were the 3 cases to take care of. Let's see if we have made any mistake or this code runs fine. Okay, one small mistake is H I have used. In fact, this is head that we are getting. So rather than H, this should be head that we should use. So let's go ahead and submit and see what happens to these test cases. So we see the test case: first pass, second pass, third pass, fourth pass. So this is the code where we have tackled all the test cases.